Okay, now let's see another example, another possible, I mean, we're using solving another game. So in this case, let's say that we simplify this with this board, and then, and again, this is giving you the power of you deciding the structures that you're going to use, how you're going to interpret. Because when you look at this, you say this doesn't look like a production systems that we were using here that says something about a condition, and then a halt. Because remember, it is up to you how you store the structure. So in this case, for example, there are two components. So I could make the interpretation that here the first element of this function move is the condition, and the second one is my action. So if I'm on 1, then I go to 8. Okay, so if one on 1, again I will go to 6. So this is one possibility, right? So this would be then my description of my production system. That can be also described as this. So if you are on a square 1, then move it to a square 8. And that's what it says here, 1 to 8, 1 to 6. So 1 can go to 8 or 6, 2 and 2, I got two options, either 9 or 7, 9 or 7, and 3, there are two options on 3, two options on 4. So each one looks that they had two options, right? So this is another way of describing. Now, let's see another way of implementing those rules for that game here. Now, over here. So let's say that initially we're on a square 1, and the goal is to go to square 2. So in this case, we can halt when we reach the goal, because in this case, if you're using the production system for this application, you want to win the game. So in this case, we're going to check, I mean, we can add into our program that says if the goal is in the working memory, then we stop. So here, we're on 1, that's what the current state. So we're on square 1. So we're right here. What to do? So I got two options, either 8 or 6, right? So if I'm a 1, 8 or 6. So these are the only two rules that matches the condition, because nothing else talks about 1. So I have in my conflict 1 and 2. And then again, if I do the first rule, then I do 1. Okay? Then when I do 1, uh, that means 1, I'm gonna move now to square 8. So now I'm on 8. So my current working memory is on 8. So in this case, the working memory is where is it, in which current state is the 9 on the board, right? So this is fascinating, I think. So you see, so 8 now. Still, this is my goal. Like I'm using this here to compare. Is 8 equals to 2? No. Then my conflict set will be 13 and 14. Why? Because 13 and 14 talks about 8, the square 8. Then I'm going to replace it with 3 or 1, right? Once I apply. So I had 13 and 14. I'm doing 13, and 13 is, rule 13 says that 8 is going to be replaced with the 3. So here is a 3. Okay, and then from 3 is going to be 5 and 6. I'm going to execute 5, and 5 is probably going to say that replaces that with a 4. And then we keep doing that until eventually I get into square 2, and that's when I halt, because that was my goal. Okay, so this is another way of explaining how is that we can go and understanding that, maybe using some type of recursion with the path and the moves, because here the path will be the interpretation that there will be a sequence of multiple moves to take me from X to Y. So in this case, maybe I want to go from point X in a given part of the game. I'm right here, and I want to go to this specific uh, state of the game, right? So there will be several moves that will take me there. So again, there are multiple ways that we can say, I mean, we can implement this. So in this case, this approach will be that we always start on that square 1. If we now make it in this way, like a recursive way, defining path, the path is going to be multiple moves, then I can define the production system being in any, not in a fixed start state, but any other way of the state of the game, right? So look at that. Now we're not using like graphs before. This is another approach that we can solve the games. Now, there are other two ways of implementing this. The one is going to be called data-driven search and goal-driven search. And for and I want to speed this up because the video is being too long. So the difference is if from a goal I go to the start, and a good example for this, let's say that you're going with a doctor and somehow the doctor has the feeling that you have a certain illness. So then the doctor is kind of following a set of interviews or tests, because the goal is like the conclusion that the medical doctor is going to have once you go there for advice, right? Because you're not feeling well. Somehow the doctor says, I think this person has this. Let's say, for example, now that is the the COVID-19. Maybe they got this in mind and they're going to start doing some tests, and they go from the beginning of the system. I mean, it automated the system, then they verify it. Okay, so the other way is when they start the procedure but they don't really know what is it that you have, so they start doing some tests and eventually they get a goal, and the goal is kind of the conclusion of what you have. You see the different approaches in here is they think, let me do the test for COVID-19 because maybe that's what you have. And then if they go to the end, I mean, like that way, that in the way that we put the information, then it is. And here is, well, we don't know what you have. Let's see what the results is going to take us to, where they take us to, which goal, because there may be multiple goals. But okay, let's see. I mean, what I was telling you is a possible application of these two approaches. I mean, the goal and the data-driven. Again, these are tools that it will be our decision depending on the problem that we're solving. Okay, so here, let's see, there is something else here. So we say that we start. So now this is the start, and then the conflict set is 6. So now this is the rule that we fire. And when we do that, we add in these elements there. So again, if we doing the example of a medical doctor, or maybe this is a lawyer that is getting some aspects of the case, what we're adding is in the memory, we're not substituting like in the other examples. We're adding this to the working memory, but we don't go and use the matching for the start anymore, but we use these elements from the rules. So here is that, let's suppose that these are the results of some of the tests. So we're not deleting that from the working memory. We want to keep that information there. Do you see the difference? So we're keeping that information. And then we're not executing. Remember that we were doing the first rule before. Now is that it's like let's say this person met this condition, it met this, the 6, that's what we have this. So now we're adding the 5, so we're executing the 5. By executing the 5, we're adding the S to the working memory. Now is and we keep adding, right? So when we execute the ones that now the matches is going to be the 2, so the 2 is being added and so on. So look at the word adding, and the last one that we're adding is the one that is being executed. And when we reach in this one, the case of 1, we halt because we reach the goal. Okay, different ways of implementing this, and this is very similar to the last one. So we have here the 1, and then again by fighting rule 1, in this case this we're adding the P and the Q. Okay, so that we see the approach that we have, and then now which one is the one that they match. So these are the rules that we have, and then we get in the 2, the 3, and the 4, and then look at how we keep executing the rules here in that different order. You see the order in which they are executed. So these are just algorithms and ways of following how is that we're gonna do the which rules is the one that is gonna be executed in the conflict setting. The other one, remember, we were kind of doing like we were eliminating those from the oops